Hello everybody, hopefully all of you are doing well, taking care of yourself and staying safe. We'll start up with our new lesson, Work and Energy. Hopefully you have your book with you and your pen or pencil to take notes and get questions and ask me if there is any question that you have. So starting up with work. Now, placing these books on the shelf can be a tiring work. You have to lift the books from the ground to the shelf. Lighter books may require less force to move, so it is less work to put them on a shelf. Now, the lowest shelf, since it is close to the ground, it is less work to place these books there than on a higher shelf. But what actually do we mean when we say work? Work is defined as a force applied over a distance. Okay, when work is done on an object, the amount of energy it has changes. Work is equal to the force used multiplied by a distance the force was applied. Here we have the formula for the work, force multiplied with distance. Now, if the force and the distance are in the same direction, the work is positive. Again, if the force and the distance are in the same direction, the work is positive. But if the force and the distance are in opposite directions, the force is negative. Now, for example, you lift a book, right? You're lifting it, it's a positive work. But lowering a book is actually negative. The unit of work are the unit of force times the unit of distance, which we can say Newton meters nm. If, let us say, if you lift a box that weighs 10 newtons onto a shelf that is 1 meter high, so using this formula, the force is 10 and the distance is 1 meter high, right? You multiply 10 with 1 and your answer is 10. So you're performing 10 Newton meters of work. Now, Newton meters are also known as joules, writing as capital J. Now, another example. Now, let us say there are many things that they seem like the work is done, but actually work is not done. For example, you have a book here. You're holding it on your head. Now, just holding up it in your head, is it a work? Lifting it from up to down, there's definitely work, right? But just holding it up on your head is not a work, right? When you lift the ball, you are applying a force over a distance, right? But when you are holding the ball, you're still applying a force, but the ball is not moving, so the distance is 0, so there's no work done here. Now, you may notice that each example of work involves an unbalanced force, right? Unbalanced forces causes acceleration and causes motion. Motion is a necessary part of work, so you will always see work when there is an unbalanced force. Let us say you're playing a game and you see that, let us say, if both of these people are applying the same force, 6 newtons and 6 newtons, so you will see that nothing is going to happen because it's balanced, right? But as you see that one of them is applying more force, let us say towards the right it's 3 newtons, right? And towards the left against the motion it's -6, right? So there is more force towards that side, so there is acceleration. This is unbalanced force now, so of course this boy or this person is going to win it. Now, work is not being done. What if you for example, if it's a balanced force, there is no work done, but if there is unbalanced force, this means that the work is being done. The same way, for example, you and your friend are applying same force of 15 newtons to 15 newtons in a football. You're pushing it and he's pushing it, right? You're pushing it, he's pushing it from the opposite side. If both of you push with the same force, the ball will not move, right? Work is not being done. What if you push harder than your friend? The ball starts to move and the work is done. So your work on the ball is positive because it is in the direction of motion. Your friend's work is negative, right? Because it's against the direction of motion. The motion, because you're applying more force, it's moving towards you, is a positive, and he's trying to apply less force on the opposite direction, so it's negative. Okay, now the total work, the total work is the sum of negative and positive. Or we may talk, for example, when we talk about the work, we can also talk the individual force, like you and your friend, how much force you are applying and how much force is he applying. Now, friction often performs a negative work on objects as you move them. Now, let us say when a car is traveling at a constant velocity. Remember, constant velocity, it's a velocity that remains same. Let us say this car is traveling 80 kilometers per hour, same speed, right? There's no difference because it's constant. It keeps on moving at a constant velocity. Now, when a car is traveling at a constant velocity, the engine, right, the engine and the friction and the air resistance may all be performing work on the car, but the total work is zero. Why? Because the car is moving at a constant velocity. There is no increase or decrease in the velocity here, so the total work done is zero. If there is a change in velocity, then yes, there might be work done. But since the car is moving at a constant velocity, there is no change in the velocity. Whatever forces are trying to apply force on this car, no work will be considered to done since the car is moving at a constant velocity. This was the lesson for today. Hopefully you understand. If there is a question, please feel free to ask it. Thank you.